The short video is about the gravitation on a round object versus a cubic object. So here I'm just showing that I turned on planetary gravitation and I really increased the gravitational constant, which really allows me nicer numbers here. So this particular planet only has 100 kilograms, but remember the gravitational constant is much larger than it really is. The mass has a really small, the ball that I use here has a very small mass, and I'm going to give it an initial velocity of -1, so to the left, and then I let it go, and the ball is doing exactly what it's supposed to be, which means it goes and it has these trajectories of upside down parabolas. I stop it here, change the velocity to -2, so I'll make it a little faster, and still it's going to be the same thing, upside down parabolas, just like it is when we throw objects. And as you can see, it goes nicely around the planet. Still increase. Mainly I do that here from -1, -2, -3 because there will be interesting things coming up for the cubic planet. So I just want to use this as a comparison. Now I actually remember to turn the gravity vector on so we can see that the gravitation always, the gravitational force vector always points towards the center of the sphere. And now -4, and now we're not going to have these parabolic trajectories anymore, but it's fast enough to actually orbit the planet. It's almost circular. I'm not exactly sure. Maybe it's slightly elliptical. Alright, so let's go over to the cube in a moment. I think first of all I have to anchor that down, and here I have to really reduce the mass so it doesn't affect the other one that I have sitting over here. Okay, that's just taking the anchor away from that ball, increasing the mass so that I have appreciable gravity from this cube planet. So again, I'm going to start with a -1 in the x direction, and remember a moment ago it was nice parabolas on a spherical planet, and here, because the surface is no longer tangential as it is in a sphere, but it gets further away from the center of this cubic planet, we have kind of rebounding, or trajectory going from left to right, and I increase the initial speed to -2. Basically it does the same thing. Notice the green gravitation or acceleration vector always pointing towards the center of the cubic planet. Okay, go to -3, and this is actually where the most interesting stuff is happening. So there it goes, still coming back. And now it overshoots past the corner, and there it goes. Again, it's actually always attracted towards the center of this cubic planet. You can also imagine that if you didn't have a ball, but you had like a person walking towards the vertex, towards the corner of that planet, that it's not just gravity down anymore, simply because the gravity is not perpendicular to the surface, but gets to a relatively steep angle, 45 degrees at the vertex, that it kind of starts to be kind of like climbing the walking. And then as you get around the vertex, you have the kind of the same sensation. You'd be sliding along the surface. And I think that's why I stopped it here, to show that gravity is pointing towards the middle, of course, but at a large angle with respect to the surface. Here at some point it starts bouncing around. Somebody could say, hey, that seems to, I mean, kind of like almost orbiting around, bouncing around. That somebody could say, whoa, that seems like conservation of energy is violated. But I think what happened is that the software uses time intervals, and so it introduces small errors, so it gives the impression as if it gained energy out of nothing. I think it's just an artifact. Shouldn't be there. All right, and finally, this was the way it jumps around there is the most surprising result on this kind of planet. And here, with increasing to the final -4, we can see that it's orbiting the cubic planet just like it did orbit the spherical planet earlier.